In this video, I will show you three aspects of high availability that exist in ClearConnect. First, I will demonstrate a fault-tolerant service, then the same service in load balance mode, and finally I'll show you the resilience even when the kernel, which houses the registry and config services, is stopped and started again. This demo is based on the subway scenario. I've written two components for it. The first is a smart card service that represents the central system for processing smart cards. Here it exposes an RPC, which is invoked every time a smart card is scanned on a subway barrier. The smart card publishes a record that contains the number of scans each individual barrier has carried out, and the running total. The other component is the smart card client, which represents the firmware in each barrier. It simply invokes the RPC on the smart card service each time a card is scanned. I've set up launchers in Eclipse that I'll use to start the different processes for this demo. First I'll start the ClearConnect kernel. This is made up of the registry and the config service. And I'll also start the platform desktop. This is our dev engineering UI, which is part of the tooling you get with ClearConnect. It gives a simple and quick transparency to everything that's on the ClearConnect landscape. The platform desktop is fully featured and allows you to navigate easily using right mouse clicks. So we can see in the video that the services are started. We've got the platform registry and the config service. Next I'll start the smart card service in fault tolerant mode. I've called one primary and the other standby. You can see that both instances have started and are in fault tolerant mode. Together they form a single logical smart card service. Now I'll navigate to the records per service and find the record called smart card reads. Okay, I'm going to start the smart card client, which represents the subway barrier that scans cards 5 times a second. When this happens, record changes rapidly. Each change is read in the platform desktop. Now when I stop the primary service, you will see that the record goes stale, yellow on the platform desktop. And once the heartbeats are missed, connections are re-established and the standby service seamlessly takes over. Now I'm starting the same service in load balanced mode. I've called one instance 1 and the other one 2. To demo load balancing, I'm going to navigate to a record per service instance. So we will see one record published by service 1 and the other record published by service 2.
Do you want a full reference number? 646.
When I start a smart card client, it is picked up by service 1. Then the next one I start is picked up by service 2, and so on in a round-robin fashion. Stopping service 2 makes the record temporarily go stale until service 1 automatically takes over.
Do you want a full reference number? 646.
Finally, if I stop the kernel, you can see that the platform desktop shows it is disconnected, but in-flight connections and data are unaffected. Eventually, when the kernel is restarted, the platform desktop shows that everything reconnects and we're in the same state before the kernel was stopped.